Okay, so moving on to the next section, we have questions in which one or more options are correct. Starting with question number 49, which says that the probability that a student passes at least in one of the three examinations A, B, and C is 0.8. So we need a Venn diagram with three sets. So let us draw it. This is a Venn diagram. There are three examinations: examination A, examination B, examination C. The student passes in at least one is 0.8. The probability that he passes in at least two is 0.4. The probability that he passes exactly two exams is 0.2. So at least 2 minus exactly 2 gives you exactly 3. That means this number here is 0.2. 0.4 minus 0.2. Now, if alpha, beta, gamma are respectively the probabilities of the student passing in capital A, capital B, capital C exam, then we have to find the relations between alpha, beta, gamma. Students, 2 exam वाला area कौन सा होता है हमारे पास? 2 exam वाला area होता है ये वाला. Only 2 exams. So let it be small a, let it be small b, let it be small c. So we know that small a plus small b plus small c जो होगा वो हमारे पास 0.2 होगा, because it is the probability that he passes in exactly 2 exams. अगर हम exactly 1 exam की बात करें, this portion, this portion, this portion, the sum of these three portions, let us say P, Q, R, is obtained as 0.8 minus 0.4, because 0.8 probability है at least 1 की, 0.4 probability है at least 2 की. So 0.8 minus 0.4, at least 1 minus at least 2 gives you exactly 1. So P plus Q plus R की वैल्यू हो जाएगी 0.8 minus 0.4, that is 0.4. Now students, for A and B option, we need alpha plus beta plus gamma. So students, in alpha plus beta plus gamma, PQR will come one time. So P plus Q plus R. ABC will come 2 times each. So 2 times A plus B plus C. And A intersection B intersection C, that is 0.2. That will come 3 times. So 3 into 0.2. So we have the answer as 0.4 plus 0.4 plus 0.6. So 1.4. That is 7 upon 5. So A is wrong, B is correct. Now let us talk about C and D. It is given that assume that the result of any examination does not affect the probability of passing of the other examination. So we can say that alpha into beta into gamma, that is probability of A into probability of B into probability of C, is simply nothing but probability of A intersection B intersection C. And that is the centermost part, 0.2, 1 upon 5. So this is the answer for alpha into beta into gamma. This option is correct. Let us talk about alpha square plus beta square plus gamma square. We can see that here, students, the events of passing of any 2 examinations or the 3 examinations are independent of each other. So this probability of A intersection B, that is A plus 0.2, is simply alpha into beta. Similarly, this probability C plus 0.2 is beta into gamma, probability of B into probability of C, and this probability B plus 0.2 is probability of A into probability of C. That is by the result of independent events. So what we get here? We get alpha beta plus beta gamma plus alpha gamma equals to A plus B plus C. What is the value of A plus B plus C? 0.2 plus 0.6. So 0.8. And we know that alpha plus beta plus gamma whole square is equal to sigma alpha square plus 2 times sigma alpha beta. So we have 1.4 whole square is equal to sigma alpha square, which is required in the question, plus 2 into 0.8. So we have sigma alpha square, that is alpha square plus beta square plus gamma square, equal to 0.36. And that is 9 upon 25. Okay. Option number D is wrong. Final answer is BC. Very good question based on probability, given that the events are independent, and further it involves a very exhaustive use of Venn diagrams. Okay. Let us move on to question number 50. Question number 50 says that the number of solutions of the equation cos cube x plus sin x minus 1 whole cube plus cos x minus 1 whole cube minus 2 cos x plus sin x minus 2 whole cube equals 0. Students, it is clear that cos x whole cube plus sin x minus 1 whole cube plus cos x minus 1 whole cube is equal to the sigma of these three, the sum of these three, that is 2 cos x plus sin x minus 2 whole cube. Which means that, so if I assume this quantity as A, so it is A cube, this as B, B cube, this as C, this is C cube, is equal to, this is the sum of these three quantities, A plus B plus C whole cube. So this is true only if A plus B into B plus C into C plus A is equal to 0. Students, clear that cos x is A, sin x minus 1 is B, cos x minus 1 is C. So what is A plus B? A plus B is cos x plus sin x minus 1, B plus C, sin x plus cos x minus 2, C plus A, 2 cos x minus 1 equals 0. Product of three terms is 0. First term is equal to 0 implies sin x plus cos x is 1. Second term can never be 0 because sin x plus cos x, the maximum value is root 2. So it cannot be equal to 2. Third term equal to 0 means cos x is equal to 1 by 2. In the given interval, if we take x equal to 0 or x equal to pi by 2, we obtain the solution of the first equation. And for the second equation, we need x equals pi by 3. So we have the total number of solutions as 3. It is less than or equal to 5, 4, 3, 8. All four options are correct. A, B, C, D is the answer. Okay. So an important precaution while solving such type of questions is that you have to carefully look at the length of the interval given over there. Okay. So let us move on to 51. Question number 51 says that if PQR are non-zero real numbers such that 1 plus P upon P, 1 plus Q upon Q, 1 plus R upon R are in AP and P by 2, Q by 2 minus R are in GP, then we have to solve the following options. 1 plus P upon P, 1 plus Q upon Q, 1 plus R upon R are in AP and P by 2, Q by 2 minus R are in GP. Students, we can see that 1 by P plus 1, 1 by Q plus 1, 1 by R plus 1 are in AP, and from here we can see that multiplying by 2, P, Q minus 2R are in GP. So we have subtracting 1, it won't make a difference to the arithmetic progression. So 1 upon P, 1 upon Q, 1 upon R are in AP, or vice versa, PQR are in harmonic progression. So we have Q is equal to 2PR upon P plus R. From here we have Q square is equal to minus 2PR. So from here what do we get? So 2PR is minus Q square. So Q is equal to minus Q square upon P plus R. P, Q, R are non-zero real numbers, so we can cancel Q here. So this will give you Q. This ultimately gives you P plus Q plus R equals 0. That's it. If P plus Q plus R is 0, option number A is definitely correct. Let us talk about option number B. I have written that PQ minus 2R in GP. If we raise to the power 3 of both of all these numbers, definitely the next sequence will also be in GP. So option number B is correct. Then we can see that PQ minus 2R are in GP. So option number D is definitely wrong because 2PQ minus 2R cannot be in GP at the same time. Okay, so this is wrong. Minus 2PQ minus 2R. Option number C. So if they are supposed to be in AP, then 2 times the middle term is equal to first term plus last term. And that is same as P plus Q plus R equals 0. These two conditions comprehend each other. So that is very much true. C option is correct. Final answer is ABC. Okay. So you have to very smartly work through the options of such question because you have to carefully check each and every one of them. Okay. Let us move on to 52. Question number 52 says that let 1 plus x raised to power n is c0 plus c1x plus c2x square so on till cn x power n, where n belongs to natural n and CR is equal to NCR. So this is just the definition of binomial expansion. If sigma r from 0 to n, CR cos r theta is equal to P theta n, then we have to find out value of P theta n at some particular values of theta and n. So we have P theta n equals, put r equal to 0, C0 cos 0 is 1, C1 cos theta plus C2 cos 2 theta up to Cn cos n theta. So students, if I consider 1 plus e raised to the power iota theta whole raised to the power n, that is C0 plus C1 e to the power iota theta plus C2 e to the power iota 2 theta plus Cn to the power iota n theta. If I simplify the left hand side, I'll get 1 plus cos theta plus iota sin theta whole raised to the power n, and p theta n is the real part of the right hand side. Okay, if we carefully observe this series, p theta n is the real part of the right hand side. So real part of this number is equal to the required statement p theta n. So what is p theta n ultimately? P theta n is the real part of 1 plus 2 cos square theta by 2 plus 2 iota sin theta by 2 cos theta by 2 whole raised to the power n. So this is 2 cos theta by 2 is common. Real part of raised to the power n, real part of cos theta by 2 plus iota sin theta by 2 raised to the power n. This is 2 power n cos power n theta by 2. This is real part of e to the power iota theta by 2 and then e to the power iota n theta by 2. So we have 2 power n cos power n theta by 2 into the real part of e raised to the power iota theta is cos theta. Cos of n theta by 2. That is the answer. P of theta n. Let us simplify the options. P of 2 pi comma 3. Option number A. 2 pi. So A 2 pi comma 3. This is 8 into cos cube, that is minus 1, into cos 3 into 2 pi, 6 pi by 2, cos of 3 pi, that is again minus 1. So it is 8. Option number A is wrong. Option number B. 3 pi by 2, comma 4. 2 power 4, 16. 3 pi by 4, cos raised to the power 4, 3 pi by 4, minus 1 by root 2 raised to the power 4, that is 1 by 4. Multiplied by cos n theta by 2. What is n into theta? 6 pi cos of 3 pi is minus 1. So yes, the value is minus 4, but if you take the modulus, the answer will be 4. It is correct. 5 pi by 2, comma 5. This also comes out to be 2 power 5, 32. Cos of 5 pi by 4 raised to the power 5. So 5 pi by 4, that means minus 1 by root 2 raised to the power 5. So minus 1 by 4 root 2 into cos of 25 pi by 4. So it is 1 by root 2. Ultimately the answer is same, minus 4. Again the modulus, the answer is 4. Pi comma 3. Because it is pi comma 3, this term will go to 0. So yes, the answer is 0. Final answer of the question, BCD. Let us move on to 53. Question number 53 says that let fx be a function which is integral 1 to x ln t upon 1 plus t dt. Then we have to find out f of 1 by x and fx plus f of 1 by x. Fx is 1 to x ln t upon 1 plus t dt. Directly substitute x as 1 by x. So what is f of 1 by x? 1 to 1 by x ln t upon 1 plus t dt. What we will do now, we will replace t as 1 by v. So dt will be minus 1 by v square dv. So we have f of 1 by x as, when t is 1 by x, v is x. So integration 1 to x ln 1 by v, that is minus ln v, upon 1 plus 1 by v, that is v plus 1 by v, into minus 1 by v square dv. So students, we get here 1 to x ln v upon v into 1 plus v dv. By the change of variable, it can be written as 1 to x ln t upon t into 1 plus t dt. So that means option number A is correct, B is wrong. Talking about their summation, we have fx plus f of 1 by x. The limits are same now. We have 1 to x ln t upon 1 plus t dt plus ln t upon t into 1 plus t dt. Students, ln t upon 1 plus t is common. So we have 1 plus t upon t dt. It is quite easily integrable. 1 plus t getting cancelled. So we have the answer as ln t whole square upon 2 from 1 to x. That is 1 upon 2 ln x whole square, and that is 1 by root 2 ln x whole square, and that is ln x raised to the power 1 by root 2 whole square. Why I have converted this into this form? Because it is given in the options. D is correct, C is definitely wrong. Answer is AD. Let us move on to 54. Question number 54 says that consider a plane P passing through point A, lambda 1, 3, lambda 2, B, minus 1, 3, 2, C, 7, 5, 10, and a straight line L with positive direction cosines passing through A bisecting BC and making equal angles with the coordinate axis. Let L1 be a line parallel to Ln passing through origin. Which of the following is or are correct? We have to check all the four options. Let us consider the line L. Line L is passing through the midpoint of B and C. Let the midpoint be M. The midpoint M of B and C is 6 upon 2, 3, 8 upon 2, 4, 12 upon 2, 6. It is passing through A as well. Lambda 1, 3, lambda 2. What are DRs? DRs are lambda 1 minus 3, minus 1, and lambda 2 minus 6. And they are equivalent to 1, 1, 1 because this particular line is making equal angles with the coordinate axis. So you get 3 minus lambda 1 equals 1 and 6 minus lambda 2 equals 1. Lambda 1 is 2 and lambda 2 is 5. After that, it is a very easy question. Line L1 be parallel to line L and passing through origin. Which of the following are correct? So if line L1 is passing through origin and it is parallel to L, these are the DRs of L as well as L1 because they are parallel. So definitely if it is passing through origin, we can write down the equation as x minus a upon 1 equal to y minus a upon 1 is equal to z minus a upon 1 because the direction ratios are also 1, 1, 1. So this is correct because if you put 0, 0, 0, you'll get minus 2 equal to minus 2 equal to minus 2. So it is fine. Lambda 1 plus lambda 2 equals 7. Very correct. We have lambda 1, we have lambda 2. Sum is 7. Equation of plane perpendicular to plane P. Now plane P is a plane which is passing through A, which is now 2, 3, 5, which is passing through point B, which is minus 1, 3, 2, and which is passing through C, 7, 5, comma 10. By the 3-point form, you can easily obtain P. It comes out to be equal to x minus z plus 3 equals 0. So definitely for plane perpendicular to P and perpendicular to the direction ratios of line L1, the DRs to the normal vector are ijk 1, 0, minus 1 and then 1, 1, 1. This comes out to be I minus 2j plus k. So yes, this is normal vector of the plane and the plane is passing through origin also as it is containing line L1. So we have x minus 2y plus z equals 0 as the correct answer. Area of triangle ABC, we have a direct formula, half of magnitude of AB cross AC. So you have all the points, you can easily calculate it. It will come out to be equal to 3 root 2 square units. All the four options are correct for this particular question. Answer is ABCD. Let us move on to 55. Question number 55 says that the solutions of the differential equation dy by dx minus 3y equals sine 2x is or are. Students, it is very clear that it is a linear differential equation of the form dy by dx plus py equals q, where p is minus 3 and q is sine 2x. So we have the differential equation as dy by dx minus 3y equals sine 2x. Students, what happens over here? Integrating factor is e raised to the power integration of p dx. So integrating factor is simply e raised to the power integration of minus 3 dx, and that is e raised to the power minus 3x. So if you write down the solution of linear differential equation, y into the integrating factor is equal to integration of q, that is sine 2x, into integrating factor e raised to the power minus 3x plus constant of integration. On the right hand side, when we are going to solve the integral, we know that we have to apply it by parts twice. The final answer will be y into e raised to the power minus 3x is equal to minus 1 upon 13 e raised to the power minus 3x into 3 sine 2x plus 2 cos 2x plus constant of integration. Students, clearly we have option number A as the correct choice. Now, since options might be interconvertible over there, so let us have another look. So let us convert the square bracket into auxiliary form by dividing by root 13. So this is simply minus 1 upon root 13 into e raised to the power minus 3x into sine of 2x plus alpha, where alpha is an angle which can be given as tan inverse 2 by 3. Carefully seeing that fourth option is also correct, because if we multiply by e raised to power 3x throughout, we get this also as the correct option. Also, carefully analyzing B option and C option, they are obviously wrong because cos of 2x plus tan inverse 3 by 2 cannot be there. 2 cos 2x plus sin 2x is not there. So final answer of the question is option number A and option number D. We always have to solve carefully with the options when such questions are there. Okay, let us move on to 56. Question number 56 says that if A is a 3 cross 3 matrix given as 1 4 0 5 2 6 1 7 1 and A inverse is equal to 1 upon 36, alpha A square plus beta A plus gamma into I, where I is an identity matrix of order 3, then a straightforward problem of Cayley-Hamilton theorem, determinant of A minus lambda is equal to 0. You'll get a matrix polynomial from there and pre-multiply with A inverse to get your answer. So what is the determinant A minus lambda I? It will be 1 minus lambda, 4, 0, 5, 2 minus lambda, 6, 1, 7, 1 minus lambda. The determinant is 0. Clearly it is 1 minus lambda into 2 minus lambda into 1 minus lambda minus 42 minus 4 into 5 minus 5 lambda minus 6 equals to 0. This will give you lambda cube minus 4 lambda square minus 57 lambda plus 36 equals 0, which means a cube minus 4a square minus 57a plus 36i is equals to 0. So from here we can have A inverse as 1 upon 36 into minus a square plus 4a plus 57i. So what is alpha? Alpha is minus 1. What is beta? It is 4. What is gamma? It is 57. Alpha plus beta plus gamma is 60. D is correct. A is wrong. B option. Number of positive divisor of alpha minus beta plus gamma. Alpha minus beta is minus 5 plus gamma 52. 52 can be written as 13 into 2 square. So yes, 2 plus 1 into 1 plus 1, 6 divisors. 1 of alpha beta gamma is a prime natural number. First of all, 57 is not prime, 4 is not prime, minus 1 is not natural. So it is wrong. Answer is again BD. Let us move on to 57. Question number 57 says that let H denotes the set of all real values of x such that 1 plus x raised to power 2016 whole multiplied by 1 plus x square plus x power 4 plus up to x power 2014 is equal to 2016 x power 2015. So definitely this is a polynomial equation involving higher degrees. Let us keep a term constant on one side and divide by x power 2015. So 1 upon x power 2015 plus x power 2016 upon x power 2015, that is x, multiplied by 1 plus x square plus x power 4 up to x power 2012, and the last term is x power 2014. Students, there are 1008 terms here and 2 terms here. I'm going to club these terms. How? Let us see. This into the last term is 1 upon x. This into this term is x. So x plus 1 upon x. You can think of AMGM inequality very easily now. This term into the second last term is 1 upon x cube. This term into this term is x cube. So x cube plus 1 upon x cube. The next term will obviously be x power 5 upon 1 plus x power 5. So you have to make 1008 pairs. So the last term will be x power 2015 plus 1 upon x power 2015, because they are only the odd degree terms present in the given series. 1008 पेयर हमारे पास हैं x plus 1 by x, x cube plus 1 by x cube की फॉर्म में. Either their value is greater than equal to 2 or it is less than equal to minus 2. Right hand side positive है, x को positive होना पड़ेगा. 1008 pair into 2 is 2016. So that means AM is equal to GM. Okay. So that means X is equal to 1 is the only possible value for this equation. Applying AM GM for all the terms, we get AM equal to GM. Now students, X equal to 1. So how many number of solutions? Only one solution. Option number A goes wrong. B is correct. C is definitely wrong. D you can easily check. XI belonging to S. So 1, 2 is lying inside this parabola. So this is also correct. Final answer is BD. Okay. Let us move on to question number 58. Question 58 says that let f be a real valued function satisfying f of x square plus y into fz equals x fx plus z fy for all x, y, z belongs to real. It is given that f of 1 is not equal to 0 then. Students, in this type of question, you just have to go by hit and trial. Just assume certain values for x, y, z. Preferably put them 1 or 0 so that you can easily figure out what will be the value of fx in this question. So I'm going to put x equal to 0, y equal to 1, z equal to 1. So if x is 0, f of 0 plus 1 f1 is equal to 0 f0 plus 1 f1. What does it give me? F of f1 is equal to f1. Let us say f1 is lambda. So what does this equation represents? F of lambda is equal to lambda. And this is going to happen for all real values of x, y, z given in the question. So fx is simply equal to x. Further, f of fx is again x. Option number A is correct. Option number B is correct. Option number C, f of x square into fx. So fx is x is equal to x cube into f1. f1 is 1. Correct. So f of x square is simply x square. X into x is x square. So it is correct. All four options are correct. Answer is A, B, C, D. Let us move on to the next section which contains match the column type problem.